Hi, I'm Prince, co-captain of Team 1792 Roundtable Robotics. For the 2026 rebuild season, our team developed many innovative solutions, but our most vital breakthrough wasn't mechanical, it was procedural. We shifted from asking, what can we build, to what will actually win. By mapping every game action on an impact ease chart, we established a strict must, could, won't list. This unified the team, forcing us to set aside individual cool ideas for a single goal, winning a Robot Blue banner at a district event. With our priorities set, the first step was to be able to drive over the bump. Initially, we assumed flipping our drivetrain bar above the wheels would provide sufficient ground clearance. While it did increase clearance, it also exposed our motors. During one attempt, we broke a motor while traversing the bump. Fortunately, the module survived. We replaced the motor, but the failure exposed a major strategic risk. Inspired by rock-crawling vehicles, we developed rock hoppers. These are motor guards made out of bent steel plates welded together to shield our motors. Testing showed immediate results. After repeated crossings, the guards remained unscratched and our motors stayed protected. What began as a vulnerability became a key innovation to this robot. Next step we took was acquiring fuel. We believe in stealing from the best and inventing the rest, so we adapted 254's 2017 design. Our initial prototype only suggested where the fuel should go, failing our touch it, own it philosophy. By quickly adding foam insulation to increase the compression, our mechanical team transformed the intake from a passive system into an aggressive one that commands fuel into the robot. To maximize our in-house capability, we designed a custom 3D printable dead axle roller hub. In previous years, we struggled with bent intake shafts and drifting wheels. By completely removing the hex shaft from the system, we created a system that's reliable, durable, and easily replaceable. Because we 3D print them, we always have spares ready, which is a key part of our strategy to always stay field ready. Moving fuel inside of our robot presented our biggest challenge. We initially modeled a complex multi-roller system in CAD, but our design review revealed a problem. It required a lot of moving parts, which added a lot more points of failure and a lot more complex to fix. In a display of mature teamwork, we decided to pivot early, from a complex multi-roller system to a simplified spindexer powered by a 23-to-1 cycloidal gearbox, eliminating backlash and jamming. This move saved us weeks of troubleshooting and ensured our system had the torque to power through any obstacle. Because we anticipated heavy defense, we ventured into new territory, our first ever turret. Space constraints ruled out our original gear-driven concept, so we designed a compact, belt-driven system with the motor tucked behind the indexer to maximize hopper capacity. Wiring the shooter motor on our rotating turret proved especially challenging. We experimented with constant tension springs and even ID badge reels to manage the wire loom. After multiple iterations, we landed on surgical tubing tied to the hopper support bars to maintain tension, along with a small brass weight to guide the loom downward and away from the moving components. This solution was simple, effective, and robust. The shooter on top underwent the most iterations. When we realized the wheels lost speed during rapid fire, we added mass to the drive shaft to increase inertia. When the field moved side to side, we add guides, initially scrapwood, then 3D printed parts. Throughout this process, our teamwork was the engine. Our software and mechanical team worked side by side every night testing and retesting until our fixed angle shooter achieved our goal. Simple, reliable, and fast. After finishing the robot's design, we focused on programming. We used an interpolation table to adjust our shooter speed based on distance, letting us score from anywhere within the alliance zone. With the use of 2 cameras tracking April's eggs, the robot always knew its position and automatically switched targets. We also limited the turret's rotation using the remainder of the input angle to protect our wiring. Team spirit is just as important to us as performance. At every competition, we hand out safety business cards to other teams to promote safe habits and hand out peer awards to build positive connection in the pits. It's a small action, but it reflects our commitment to looking out for the entire event. We also bring strong energy to the stands with a dedicated crew cheering every match. They lead chants, celebrate big plays, and keep the morale high even during tough rounds. Their support fuels our drive team with confidence and shows that we compete with both excellence and enthusiasm.